Hello, this time we have a stats question. A flight back to the UK from Paris costs £100, but oh no, Mickey the Mouse stole your wallet at Disneyland. What a travesty. You're down to the last £20 in your back pocket, and of course desperate. A shady local offers a solution, a game of chance. So, you just place a stake, and a fair coin will be tossed. If the coin returns heads, you win back your stake plus its value. If the coin returns tails, you lose the stake. So what that means is that if we start with £20 and we stake £5, then we either end up with 25 or 15. So we either gain or lose that stake. The game is repeated as many times as necessary. So either we're going to get £100 and get back home, or more, and we stop playing, or we run out of money and get stuck in France for the rest of our lives. A fate worse than death, clearly. So now that we've set the scene, what are the questions? So for each of these strategies, we want to find the probability of being able to afford the flight. So the first strategy is if we don't have enough money for the flight, we stake absolutely all of it until we either win or lose. So what does that look like? Well, we start off with 20, and we have a half chance to completely and utterly lose it all, so we end up with 0, or we have a 50% chance to end up with 40. From there, we can either stake all of it and lose it all, or we can get to 80, and finally, we stake all of it, lose it all, or we get to 160, which is definitely above £100, so then we win. However, we've got a 60 surplus here, which, isn't really necessary. It's a bit wasteful, but oh well. We'll see what the probability of this is. Well, this is a half chance, this is a half chance, this is a half chance. So to have all of these three things happen, it is a half power of 3, which is equal to 1/8. That's the probability. Now for method 2, which seems a bit more sensible. If we have less than £50, we stake all our money, otherwise stake what would win you enough money for the flight. So what this means is, as before, 20 we can lose or get to 40, 40 we can lose or get to 80. But now from here, we only stake what will win us enough to win money for the flight. So here we stake 20, and if we win, we get 100, we're done. Or we lose 20, so we go down to 60. And again, at 60, we either stake 40 and win, or we lose and we go down to 20. Well, from 20, we lose or we go to 40. From 40, we lose or go to 80. From 80, we can either win or go to 60. And from here, we go to 20 or 100. Oh, we're repeating ourselves here. It's like some sort of loop. How do we deal with this? Well, let's start by calling the probability of starting here and winning, starting at 20 and winning, let's call it P. Now, every step down this tree has a probability of half happening. So, if we take n steps down the tree, then it'll be a half to the power of n of it happening. We can see that the probability of going back to where we started is, well, 1, 2, 3, 4, so 4 steps. What this means is that the probability of P is equal to going 3 steps to 100 immediately, so that's a half to the power of 3, or we take the third step down here, and then we go here, so that would be a half to the power of 4, so that's 4 steps, or we take the 4th step and we actually end up at 20, and this is where, from there, it takes P to get there. So this would be a half to the power of 4 times by P. And now we can simplify the equation. So P is equal to 1/8 plus a 16th plus a 16p. And we rearrange and combine for 15 over 16p is equal to 3 over 16, and we get that we have P is the 5th, so 1/5. Now for part C, if we have, this is slightly different again. If we have less than £50, we stake all our money, so let's just write that out now. £20, £40, we're now at 80, Otherwise, we stake £20 until we have enough. So here we will stake here and we get 100. Here we go down to 60. And this time we don't stake what we need, we just stake 20. So we could go up to 80, and then from there we could go to 100. Or we could drop down to 40 here. We could drop down to 60 here. And in fact, we could either keep on going between 60 and 80 forever. We could also win here, and so on. We could also drop down to 40 here, drop down to 40 here, and so on. I'm not going to draw what happens after 40 because when we go to 40, we go back to this square here. So again, we'll call 20p. And, well, what would 40 be referred to as? Well, from here, we've taken one step forward, and we're guaranteed to have taken one step further towards our goal instead of getting bust. So this is actually twice the probability of winning from 20, so this is 2p. Now, using this, let's start to trace out the paths. So we have the probability of winning, p, is equal to, well, we have 1, 2, 3 steps, so that's a half to the power of 3. And if that fails, we could just then take 1, 2, 3, 4, 5 steps, so that's a half to the power of 5. And if that fails, we could take 5, 6, 7, so half to the power of 7 steps, and so on. This thing keeps on increasing, 3, 5, 7, 9, and so on. Now, the more interesting case is when we win, lose, lose, and from here on out it takes 2p to get there. So this would be 2p times a half to the power of 4. If we fail a little bit further down, that's 2 more steps, so that's 2p times a half to the power of 6 plus 2p times a half to the power of 8, and so on. But this, we can cancel the 2 and the half out, so there's actually just p times a half to the power of 3 plus a half to the power of 5 plus a half to the power of half to the power of 7, and so on. So it's pretty clear we need to simplify this infinite series. What is this infinite series? Well, we have that the first term, a, is a half to the power of 3, so that's an eighth, and the ratio between terms, that's a half to the power of 2, so that's a quarter. And the infinite sum would be a over 1 minus r, so this is an eighth over 1 minus a quarter. And very quickly we can see this is going to be a sixth. So I'll put the last bit up at the top here. We have that p is equal to 1/6 plus a sixth p. And rearranging, we get that 5 over 6p is equal to 1 over 6, or that p is equal to 1 over 5, just like before. Now, bringing everything together, you can see all three strategies here. Which of the three strategies is the best? Well, we know that the first strategy had an 8th probability of winning, the second strategy had a 5th probability of winning, and the third strategy also had a 5th probability of winning. So that rules the first one straight out. Clearly, it's not the best to have a high probability of losing. Now, best is a bit subjective, but you might have noticed that it generally could take quite long for strategy C to result in a win. Even though it had the same probability, it generally would take more games being played for us to win. And I'm not going to go into proving this mathematically, but you certainly can do that. It's quite intuitive with the way that you can see that we have two opportunities with strategy B when we state what we win pretty much immediately, whereas with C we end up sort of, teetering back and forth. Sometimes we might end up never actually reaching the end in a lot more cases. So overall, we can say that strategy B is the best strategy. Of course, that depends on whether you care about the amount of games you need to play. Can we think of an even better strategy to improve our odds? Well, This is more of an extension question, but as it turns out, we can't. B is actually the best strategy that we have. And this might be quite surprising. And if you find this interesting, I would recommend looking into something called Markov chains, which explore this topic in a bit more detail. Another thing you might want to do as an extension is instead of having, a half head, half tails, what if we used a biased coin? How would that affect the probabilities? And would it actually change which of the three strategies becomes the best? You could also experiment with different starting amounts and see how that affects things. So for example, it's weird how if we're starting at 20 and want to get to 100, well that's a 5 times increase, and the probability just happens to be 1/5, the best probability we can get. So is there something going on there? If you do have any comments about these, feel free to comment down below or just send me a message. Take care.